heard it before I can go about it.
With your permission, why don't we start? I'm David Zlow. I'm the program chair for the Classic Society. Thank you all for coming, and most especially thanks to Thomas Lera for agreeing to speak with us today. A quick pitch: tomorrow at the same time in the same room, we'll have the 17-year-old Casey Cook, who is the youth.
Young Philatelic Leaders Fellow.
Okay, of the Classic Society. It has a wonderful presentation on postal history from generation to generation. I hope you'll join us tomorrow. And then at the other extreme, perhaps, if John doesn't mind my saying so, John Birkenbein II tomorrow at 3 p.m. Will be talking with a little bit of an East Coast emphasis on the transcontinental mails from San Francisco and the gold regions. So that should be a very interesting talk as well. Today we have Thomas Lera. Tom was appointed the Witten and Blount Research Chair at the Smithsonian National Postal Museum in 2008. He has written over 100 articles and papers which have been featured in leading philatelic journals. Recent publications include the G.H. Caseland collection of Russian Imperial and Zemstov stamps with co-author Leon Finnick, and Spanish-Philippine postal issues, the genuine surcharge types of 1881 to 1888 illustrated guide with co-authors Don Pedersen and Nigel Gooding, which is in publication. In 2012, Tom was the co-chair of the International Symposium on Analytical Methods in Philately, held at the National Postal Museum. He is a national philatelic judge, has been a member of the Committee of Accreditation on National Judges and Exhibitions for the American Philatelic Society, was a past president of NAPEX, and is a member of several philatelic societies, including the Royal Philatelic Society of London. When not working at the museum, this is interesting, by the way. When not working at the museum, he has acted in the preservation and conservation of caves and bats. In 2006, he was appointed by Governor Mark Warner as chairman of the Virginia Cave Board. Did you know we had one? And has been the administrative vice president of the National Speleological Society, receiving their prestigious individual conservation award. He is a fellow of the NSS and the Explorers Club in New York. He holds degrees from the University of Illinois and the University of Pennsylvania. Ladies and gentlemen,
this talk is going to be an open talk about what the lab at the National Postal Museum has and how the equipment works. So the first question I have is, how many people have been to the lab and used the equipment? Look, turn around and look. And or. A lot of people, maybe 25% of the people here have used the equipment or seen the equipment at work. The lab, this is what the lab looks like, and there are 5 pieces of equipment in it, going from a VSC 6000 1600X microscope that's attached to the VSC 6000. This is a laser pointer at that. Can you see the red light? Mm-hmm. You can? No? I didn't think so. Anyways, we got that. We have a micrometer, which is the same micrometer that is used at the Bureau of Engraving and Printing to determine the thickness of the papers or other cash currency. We have X-ray fluorescence and XRF, which analyzes elements on paper and in ink. And we have an FTIR, which is a Fourier transformed infrared spectrometer. In case I took the slide out. Anyways, we have that. The micrometer. Very simple micrometer. It works by on, off, on, off. And what it does is it measures the various thicknesses in paper and stamps and etc. I did a study on the Chile stamps. Chile, the first issues of Chile. And these were the issues that were printed in London. They were all mint stamps. And you can see the thicknesses of the different papers, and you can see the variation. The variation is, I made it look extreme because I measured it down to 4 decimal places, 1/10,000. When you normally do your study, you normally do it in hundreds. But you can see the differences here. The anvil is a wide anvil. It's not like the current micrometers that everybody has in their desk drawers where you screw it and you take a reading. This one is almost a 3/4 inch anvil, constant pressure. It follows TAPI standards, which are set up for single paper analysis. And it goes up and down at a certain rate, and you do your analysis there. Because the anvil is so wide, you can also study salvage of stamps, so you can look at the paper. Because remember, when you're using a micrometer, you're studying not only the ink, but if there's a cancellation on the stamp, that's going to increase the thickness. If there's a hinge remnant on the stamp, that's going to increase the thickness. There are various, if there's gum on the back of the stamp, that increases the thickness. You know, so you have to take this all into consideration when you're using the micrometer and you're using your study. The machine is also set up with an Excel spreadsheet. All the information gets dumped into an Excel spreadsheet. And that spreadsheet has, I put in 25 different mathematical formulas. So you can take the data and you can run standard deviation. You can run min-max. You can set up a whole different things on the spreadsheet, and it's all transportable to your flash drive, and you can take it home and play with it. Anyone have a question on the micrometer? $4 grand. Not very expensive at all.
The
Not very
anvil
expensive.
diameter seems,
Pardon?
the anvil diameter seems large to me. Does that get into perforations make it a problem? Because a lot of stamps are small enough that you're going to have to hit perforation for edges.
Well, I normally say that when you're looking at margins, you know, you try and find salvage on the stamp.
But that's a half an inch. So my salvages may not be that large.
What about margin salvage? Margin stamp?
Yeah, I'm saying the margin could be a quarter of an inch.
It'll still, you can have it partially underneath the anvil.
Okay, so it doesn't have to be the whole.
It doesn't have to be under the full anvil. You can handle the partial.
It will measure things that are smaller than half an inch.
Yes, it will. Yes, it will. Here it is. The electromagnetic spectrum. This is the only technical slide in the show, all right? And the electromagnetic spectrum deals with light. So what machines do we have that cover the electromagnetic spectrum? If you start off with X-rays, we have the XRF. If you then move into the visible spectrum, which is ultraviolet and near infrared, we have the VSC 6000 that covers that. If you look at infrared, we have I'm going to use the acronym here, the FTIR, which covers infrared spectroscopy. We don't cover gamma rays, and we don't cover radio waves. That has nothing to do with the type of analysis that we want to do. But this analysis can be done with any of our pieces of equipment in the lab. The video spectral comparator, 6000. This is an instrument that has 24 light sources. It looks at visible light spectrum, and then it can look at a little bit of infrared and a little bit of ultraviolet. So you got this whole spectrum you can look at. It has 24 different light sources, so you can put side lights on, you can look at it from underneath, from transmitted light or reflected light. It's got all this stuff attached to it. It's got here's some of the capabilities. You can see grills very clearly. You can look at this Spanish-Philippine stamp, and can anybody read the yellow surcharge on it? But if you remove all the color and look at it in the infrared spectrum, you can very clearly see the surcharge on the stamp. And that's what the book, John Peterson, Nigel, and myself are coming out with something on Spanish-Philippines, which should be coming out shortly. And then the Vincent Green Foundation also produced the VSC 6000. And at the first IAP symposium, they did a presentation on a number of stamps, one of them which was this whale stamp. It's very interesting about this stamp. There are 21 different security features on this stamp. I'll show you a couple of them because I had a copy of the stamp and I ran some studies on it similar to what they did. First of all, in the ultraviolet, there's an ultraviolet band that's there, and that is the scientific name of the whale. It also has a scientific name where all the yellow bands are. There's also a diver up on the stamp, which I'm sure you didn't see on the original stamp, Even though there are divers here in the salvage in the margin, there's one hidden on the top of the stamp. Another thing is that there's this whales eat krill, and there's this red krill cloud over there on the right-hand side of the stamp. All comes out under ultraviolet. We have 4 different ultraviolet sensors in the VSC 6000, and this is at 365 nanometers, which is at the upper end of the ultraviolet that we have. It also has, if you use another light on the system, you can see the white belly of the whale. And you didn't see that when you first looked at the stamp, did you? You can also look at various taggings. And so I've shown some taggings. You can identify scrambled indicia. The horror stamps of the U.S. had, Dracula, Frankenstein, Wolfman. And on Dracula, there were a couple of bats hidden in the scrambled indicia. You normally had to buy their secret decoder to see them, but you can also pick them out here. And you can also come up, if you use UV fluorescence, and look at various stamps under the visible light. This is what it actually looks like. Then if you go into the infrared, taking out the purple out, you can see the cancel. If you go into the ultraviolet, you can see a red, and if you go into another ultraviolet field, you can see the red, and it sort of suggests that red lake, or madder lake, was used in the coloring of the stamp. If you have a bunch of different dye samples, you can make up your own spectrum and then keep that spectrum and match it to your stamps. The machine will store all this information for you so you can compare against it.
So when you use this machine, is light transmitted from behind, or is it transmitted from above?
It's transmitted
Can
from
you repeat the
above,
question?
from the sides, from the back, from side lighting, all individual light sources,
Okay.
and from
Sorry,
underneath.
so the question, I'm trying to understand why infrared makes purple go away. And my guess is
Because it's got a filter on it. There's a filter on it. And you can remove light all the way up to 1,000 nanometers, depending upon what you want to remove. You can go through the entire visible light spectrum from 400 to 1,000, and you can put on different filters, and it removes, it's like a camera filter. It blocks it out. And you can block it out all the way up to 1,000. So remember the stamp? No red krill, no diver, no yellow lines. There's micro printing up on the top here that lays out the scientific name of the bat. And you can also do measurements in millimeters. If you want to count perforations, you can do all of that, and it'll remember all of that, and you can set it up and format it the way you want it to. See if you have perforation variances and differences. And this is how detailed you can go. And you can vary the scale. Just a little dial. All of the machines in the lab, trust me, you cannot break. You can't break. It's done, and Ross and Polo agree that, you can't break it at all. But because they're all Windows driven. So if it makes a mistake, you just reset and go back to the beginning. We all know about this stamp. Danny Redding brought the stamp into the lab, and I played with it for 3 hours. And as many of you saw the catalog that was given on the Mauritius, most of the pictures, scientific pictures, were from our lab, and he credited the lab with taking the pictures. So you can see that if you have a partial cancel, you can fill out the size of the cancel, and it'll tell you the radius of the cancel, and twice the radius is the diameter of the cancel. And many of us are concerned if it's a 29 millimeter, a 30 millimeter, 31.5 millimeter, you can tell that only from a partial cancel. And taking the infrared light, it removed all the red color, and you come up with that.
So can we assume that the British Guyana has been certified as genuine by the Smithsonian Institution,
No,
therefore?
you cannot assume that. I did not certify it. The Royal certified it. I did not certify it. I only recorded a whole bunch of readings from it for posterity, so if it comes up again, we can see if there have been changes made to the stamp. Here's some of the markings on the back of the stamp. And I'm sure you all saw some of these. There's a whole bunch of different markings. There's the Ferrari leaf, you know, there's the FK for Finbar Kenny. You know, this was done by Heinz's widow, and if you look sort of close, you can see an AH up there, which is Alfred Heinz. You know, you can see the Irving Weinberg IW down there. And of course you can see, or not to see, but there's the DuPont signature right there. The last owner of the stamp. This sort of proves that the stamp was in the lab. And you can see it up there on the video spectrometer, the VSC 6000 screen. It's a 30-inch screen, so you can see a lot of things with the screen. And then we ran it on not only the XRF, the X-ray fluorescence, we also ran it on the FTIR. And a simple study of this shows, this was the front of the stamp, the reading from the front of the stamp. It's pretty noisy. And if you then go into your library to search to see what you have, one of the readings come up hydrocarbon, and you have your hydrocarbon peak here. And you have a small hydrocarbon peak here. This one's actually a large hydrocarbon.
What are the two axes on that?
The axes are reflectivity. They're wavelengths, it's reflectivity.
And then X would be wavelength?
This is the wavelength, yes. Different wavelengths. I read it from 4,000 to like 400 wavelengths.
Oh, so an increase in.
Is it an average across the whole stamp? Is that what?
No, this is only a 1 millimeter square area of the stamp where this reading's taken.
And it's averaging across the 1 millimeter?
Yes. I did 40 scans, so the scan's going 40 times, and it comes up with this. That's how come it's so noisy. I should have ran it a little bit longer. But David Redden was, really careful about the stamp. He didn't want damage on the stamp.
You usually run, when you do these things, you usually run half a dozen, 3, 4, 5 places on the stamp.
Correct, I do.
Just to make sure you have those.
The concern was too much light on the stamp?
Well, this was infrared light, and he didn't understand the scientific principle behind it, so he was just being careful. He touched it with his gloves. I never touched the stamp once.
How long was it exposed to the shorter UVs? You poked the violet, that would tend to bleach the ultraviolet.
If I looked at it under ultraviolet, yeah, it would have done something. But we were only leaving it in the VSC 6000 for no more than 30 seconds. We'd get our picture on the screen, I'd save the picture, and we'd move it out and talk about it. And then we'd go back in, and I'd take a different reading and pull it out.
So it had a total of only about 30 seconds of UV on it, possibly?
At most it had 30 seconds of UV.
Okay.
In the VSC 6000, over the 3-hour period, it probably had, 4 minutes of light on it. Not much at all. It's the same amount of light as, taking it out now and holding it down. We were very careful not keeping it exposed to a lot of light.
Okay, you might want to paint that out.
Okay. The VSC 6000 also allows you to do a spectral analysis. And here's the study I was working on the Chile stamps again. And we take the study where the crosshairs are shown there, and depending upon the magnification, depends upon the area that you're studying. So you can go all the way from 2 millimeters to 40 microns. You can do your study. And as you move it around the stamp and save it, you get different reflectivity curves. And the machine then has a bunch of functions built in where you can run standard deviations and you can run averages. So what we normally do, and you have obviously 20 different locations you can do studies with. Sample. So you can sample, if you're taking 5 samples of stamp, you can study 4 stamps on one graph. And you can save them and display them however you want. And here's one that I did on Mauritius stamp. And question was, what has the cancel been modified? So we looked at the cancel and ran some curves on the cancel, and you can see the original cancel had that reflectivity, but then the modified cancel had a different curve. And if you look at it under high intensity, you can see where the person put his compass in the center of the stamp, because there's a little hole there, and he redrew the circle around it to make it a perfect circle around the stamp. But you can pick out the different inks.
It looks like he was fairly close though in capturing.
Yeah,
The overall shape is pretty good,
yeah,
but it's
Yeah.
just.
but it's been modified. And if you really look close, you can see where this portion of the stamp's been painted in. But what I wanted to prove was that if you use the spectrometer properly on the machine, you can pick up differences. As you can pick up differences between genuine stamps and counterfeit stamps.
So the different lines were different places on the stamp?
Yes, each line is a different spot.
On the cancel itself,
Pardon me?
on the cancel.
On the cancel.
Place
On the cancel.
And you.
So I was
that's
running
like-
it up at a high magnification, maybe 10 power, to make sure that the target was totally on the cancel, not on the orange.
So Tom, I assume that the basic premise, the basic hypothesis was that the cancel was strengthened, and you looked at it to see if you could determine whether, if in strengthening it, the later ink could be discriminated from the original.
Correct.
And you were able to do that.
And you ran
If
that
the guy,
on,
if the guy didn't improve it, he probably would have sold for 600 plus. And since he did improve it, and since it's been painted in, it's probably selling for 60 bucks.
How much of that was painted in?
I think all of this was painted in.
Oh, including the P of the, part of the P of the pay.
which machine did you run that on?
The VSC 6000. Okay. Using the Leica microscope, which goes from 78 power to 1600, you can pick up various variabilities and various questions that you may have in the ink. So looking at chili number 11 there, looks like a golden yellow stamp, goldenrod color stamp. But under high magnification, you see a bunch of red spots in it. And if you look at a lot of other South American stamps, they're yellow stamps, you'll see a lot of red spots in it. And the red spots are actually vermilion. And I'll show you the reason why, because you have to remember that the scientific instruments complement each other. So here I have red pigments, but I don't really know what they are. Why are they red? And why are they in the ink? If you go to the XRF and you look at them, you come up with very high peaks of mercury. And if I looked at the rest of the spectrum going that way, I'd have a very high peak in sulfur. And mercury sulfide, which is cinnabar, which is a vermilion ink. So it confirms that the red particles in the ink here are mercury sulfide, as opposed to the green ink, which is a Prussian blue that's been high temperature turning into green, has a high iron compound in it. So the XRF allows you to identify elements on the periodic table. Okay, you can look at the elements going from sodium down to past uranium. It will not look at the light elements. So if you have carbon and nitrogen, those elements, you can't see any of the light elements. You can't see lithium or anything like that. So you can see all those, and it penetrates the entire stamp. So it's a field instrument. This is like a Star Trek, laser gun. You can put it on a stand, you can put it on a tripod, you can hold it in your hand. I've had this even in the cave. Believe it or not, I've had it in the cave looking at stalactites to see how much calcium carbonate's in the stalactites. But it also has a pedestal that you can lay the stamp on. The X-rays come out of the machine, and it'll go about 1.25 inches, 1.5 inches above the stamp when you do the measurement. It's known as depth of penetration. So you're measuring everything, the paper, the gum, you're measuring everything on the stamp when you do it. And you normally measure the front of the stamp and the back of the stamp. So if you can determine, how much paper contribution is in your readings. So here we do.
X-ray, how powerful is that? Is that a health hazard?
No, not a health hazard at all. When you get your, this throws out X-rays from 0 to 40 kiloelectrovolts, keV. Okay, when you have your chest X-ray, you normally have them at about 120 to 150, and they're pumped out at you at about 1 amp or 1.5 amps, so they get a depth of penetration. They need a strong X-ray. This goes from 0 to 40 at half a micron. Half a keV reading, half an amp reading. So you get very, very little. I could hold my hand over it and there wouldn't be any damage whatsoever. I have a dosimeter right next to the machine. I don't know if I had it on there. Attached to the tray of the machine, I have a dosimeter, and every 3 months it gets changed out. And the readings of the dosimeter on the window ledge are heavier than the readings that come out of this. Okay, so this is extremely safe. As you see, the little triangle here means that the X-rays go that way, and you're sitting in front of the machine here, so you're not even in the range of where the X-rays are going. That's one of the reasons for having the tray there. If the tray was, if the machine was turned around 90 degrees, the X-rays would be going out towards you. You really don't want that on a constant basis. So this tells you which way they go.
Tom, you mentioned the range of the X-ray was 1 inch or so.
Yeah, 1.25 inches, 1.5 inches high, yeah.
Could you explain your comment about looking at that stamp and seeing the contents of the paper?
Well, you have to remember that the X-rays are reading what is hitting first, okay? And the ink is on the bottom, it's reading the ink first, and it goes through and reads some of the stamp, and you get that. If you turn it over, you find out how much paper it's reading, what the elements of the paper are as opposed to the pigments in the ink.
Both basically goes through the paper and the ink.
Right, goes through the paper and the ink, but the curves will be lower when you turn the stamp over. Your iron curves will be lower, so your calcium curves will be higher because you're reading more of the paper.
So you can differentiate in terms of you can use it to determine the papers.
No, you can determine binders in the paper. You can determine if it's a calcium binder or if it's a calcium sulfate binder. You can make a presumption of that that's what it is. And then you have to do your historical research and come up with what it actually is. Okay. So here's something I worked on. This is the Douglas stamp. And in 1980, EPA came out and told the Bureau of Engraving and Printing to take all the heavy metals out of the stamp. We don't want any heavy metals in your stamps anymore because too many kids are licking them and eating them. All right? Because they like the gum like this. They thought it was chewing gum. So we did a study. And we looked at plate blocks. And there were 10 different plate blocks that we looked at. And it's very easy to see the differentiation. 1980, and reformulated ink, the old ink. And you can see the lead, the iron, the molybdenum, the chromium. You can see all that. And you can see how they removed it. And how close they were in getting the colors back to the original color. They increased the iron, obviously, because the iron peaks are higher, but they also added a lot of organics to try and get the color back to the original color. And there will be a paper coming out on this. And it'll be published, we hope, in the Stamp Specialist, the U.S. Stamp Specialist.
So the green is the original?
Yeah, I should have had a line drawn in here, but this is all original.
Okay.
All the original, and then 1980, the last 4.
So that's to the left is longer wavelengths.
Pardon me?
What, on the x-axis, what's your variable there?
On this, these are plate block numbers.
Oh,
Okay?
okay.
These are plate block numbers, these are counts. the count of the number of chromium ions that it read.
Oh, you're looking at chromium here for exclusive.
Chromium, iron, lithium, lead. Wrong way. So we did that, I looked at that one, and then, of course, I looked at the Marshall because it's part of the same series. And there's only 8 blocks to look at. And the dull and shiny are the different gums on the back of the stamp. But you can see they did the same thing. They removed the chromium, they removed the lead.
On this one, the third and fourth look different from the first and second, so that means there's 3 different things.
There could very well be 3
The
different
third and
things.
fourth have a lot of zinc,
They have a lot of zinc.
and the
Yeah.
first 2 don't have any zinc.
Right. So it could have been,
Even though we don't know there's a difference, in theory, these could get different Scott numbers if you did this analysis.
it's very possible that they may have different Scott numbers for
So
the
when
colors.
else do we make portable so I can take it to the show?
Okay, but the, what does the bottom line say here? There was a tagging agent applied. Okay, and the tagging agent is applied here. So that's why there's the zinc there.
So it's all realistic.
Yeah. Oops, they go the wrong way each time. So then I decided to look at forgeries using the XRF. And Don Peterson was kind enough to give me some Spanish Philippine stamps, and you can see the major differences in the Ftir forgeries versus the original ink. The original ink was the blue, and I'm sorry, the genuine is the red, and the forgeries are the blue. And you can definitely see in the forgeries, there's more barium and more mercury. The barium could be affiliated with the paper, but there's definitely mercury, and in the original, the genuine sample, there's no mercury. And if you look closely here, you can see there's mercury and there's sulfide. It's a vermilion color that was used to make the forgery. Then looking at the Spiro Brothers on some El Salvador stamps, you can see the differences in the inks there. What I'm trying to say here is that if you have a database of forgery stamps and you have them using the XRF, you can take your patient, your unknown, and run it up against the forgery, and you can tell whether or not it's real or it's counterfeit. Because the machine allows you to have a sample behind and a current sample is running, so you can compare right away. And you can make that comparison in 20 seconds. And you don't have to, visual examples or visual decisions are easy to make on some of them, but on some of them they're real close. But here you can see, you can make it.
Is there anything on the market that the average guy can buy just to check a couple of these things?
Not that I'm aware of.
So
But you can always come to the museum.
how much is this machine?
How much is it charging?
50K.
That's all.
So you can sell 2 covers. Or 1, yeah.
So do you have to measure these at the same place each stamp to get the comparison?
Well, you would want to measure it against this, yes. Yeah, forgery of 1, you need to measure it against a genuine stamp.
But the same place on the stamp?
No, not necessarily.
Because the ink should be the same.
The ink should be the same across the entire stamp. Yeah. Yeah, so here's some sporadic forgeries of the Confederate number 9.
Could you go back 1 slide? If you're trying to, can you prove pretty conclusively that since, let's say the 5 cent 47, the inks were basically hand mixed if a daily basis every other day, can you use this to try to say that 2 stamps or 3 stamps or 4 stamps came either from the same printing, well, it came from the same printing of the days?
I don't think you can. Can you tell the difference when you have them right now, that they came from day 1 versus day 4? Can you make a visual?
Different
No,
batches.
no, you can't.
Different mixed up ink batches of what would normally be the same, are supposed to be the same ink. but they mix them up different days, so there's another way to remove them.
No, but it's basically, they all have the same pigments in it, and this is just measuring elements in the pigments.
Well,
That's all it's
okay.
doing.
I'm a step ahead, I'm
Yeah,
sorry.
you're a step ahead.
Step ahead.
You can do that with, and I have done it with a stamp that was printed, let's say, 10 years ago and
Yes.
printed today.
Yes.
I can tell the differences there. But, the other ones, no.
There might be small differences in the amount of intensity.
Right, there might be small differences, but you'll still have the same,
The bars will still be in the same positions, but they might
Absolutely.
be a little bit different.
absolutely. And, let's look at sporadic, because sporadic, everybody knows about sporadic forgeries. And here you go, you can see them. And the 3 different types of sporadic forgeries were here. You can see he even had variety in his ink that he was using. Okay, and these charts were, there's only one known of type C. And I had 3 examples of type B, I had 9 examples of type A, and I had, 20 examples of the genuine. So they're basically averages, but you can see the genuine has a lot of lead in it. And then, the sporadic had a lot of lead in it, but then again, it also had a lot of zinc in it. And he was closest here. These were just way out. And it could have been the paper he was using. And it could have been the batch of ink and the timing he ran it, because he ran his forgeries multiple times, multiple prints.
How long does it take you to run an analysis?
I normally run the analysis for 3 minutes, but I can't, you pick the time. You can run it from 20 seconds to, I normally run for 3 minutes because I'm concerned about the impurities that are in the pigments. I want to make sure I'm picking up the tiny, tiny, tiny pieces that may be in it. Is there bituminous in it? Because that was associated with silver. So, I try and get it in order to grab these tiny heights here to see if there's a difference.
I see you've got 3 minutes written.
Yeah.
So can you take a bar chart, one of these, and say, okay, B is always going to look close to what is there right there?
Yep.
Okay.
Yep. In this, using this machine, you get an Excel spreadsheet, and you can chart the graph, the data, however you want to chart it. You can chart it as points, you can use scatter points, you can chart it however you want. You get an Excel spreadsheet with every element that's read on from the instrument.
What's important is the ratio of the intensities are different.
Yeah, and you can calculate the ratios on your spreadsheet.
Yeah, you need that.
You can do all of that. All of that's given to you. It's just one click of a button and you get the spreadsheet. We call it, in the technical terms, it's the region of interest. So remember, looking at remember the mercury peak that was here? It was a red peak that went up like that. So it's getting how much mercury is in it from the region of interest. It's calculating all that. And the machine does all of that for you. You don't have to do anything other than press the button.
Resolution bandwidth.
Right, right. Okay, the last one is,
Tom, can I ask one question?
sure.
Would it be preferential to have a smaller card? I think you said it was 2 by 3.
It's, the size of this one is 2 by 3. You can't get any smaller than that unless you had a mere $250,000 and a lot of room in your lab to buy an Artex, which has a microscope on it so you can go down to 40 nanometers, and it has to be helium cooled. And I don't want to have a helium tank in the lab.
But you found this plenty adequate.
For stamps, it's pretty adequate because you're measuring a whole number of different places on the stamp. Now, the good thing is you could also measure stamps that are on covers because the machine, we go back to the machine, has a camera underneath it where the tube is, and you can use the camera to locate where you want to position it for the study.
How much variability do you have in moving that spot around, how much of a field of view total? So maybe about 2 inches by 2 inches? something
Well, no, the stamp's an inch and a quarter by an inch and a quarter. There's your variability. I mean, you just physically move it. Okay, obviously, it's turned over. So with the camera on, you can see where you are on screen or just stand up and look where the light's showing through.
See, it looks like you have a glass plate that comes on top of it.
A lot
Is
by
that
what?
mounted?
This is a mount.
Okay, so if you put a cover in there, you're gonna be damaging the
Yeah,
cover.
how big?
How big
No, it
should
doesn't,
the-
I mean, there's ways to put a, Ron will agree, there's ways to put a cover on here. And what I normally do is I put some small weights on the side of the cover to hold it in place.
Okay.
Because the X-rays are going this way, so I've had big covers on here.
You're not putting anything over the stamp after.
Not putting anything on the
Okay.
stamp, not putting anything on the stamp, no glass cover slip, no.
That'll
nothing
just
on the
throw
stamp.
everything off.
Yeah, I mean, just
Nope, you just put it there. And with covers, you can actually physically hold it there if you want to hold it there. There's no damage.
Since we talked before about the X-rays actually going a few millimeters above the stamp, the question then would be, if you're talking about a cover, how much out of what you're measuring when you measure a stamp on cover is
The cover?
the paper of the cover itself?
Well, that's the reason why, Mark, when we run the studies, we do the stamp and then we do a run of the cover to determine how much influence the cover has on your data. We have that, run that.
What chance is there that the atmosphere affects?
None, because it's run in the vacuum. I was just with a college student from Melbourne last week. She's an intern at our lab. And she brought in her XRF data that her college professor ran for her. And she was looking at Egypt #1, which is the pyramid stamp. It's red, it's green, depending on the value. And she was looking at #1. And she said, I don't understand this data. And I said, why? He said, because I don't understand what these peaks are. And I said, well, that peak is argon. And that peak is bituminous. And she said, well, how can it be? And I said, because it wasn't run in a vacuum. And it wasn't run in a vacuum. I said, if it's in argon, argon's in the air. 9% or 0.9% of the air is argon. And the machine will read that. It'll read that. But there's a feature that you can use where you can run it in a vacuum. And I always have the vacuum pump running. The other feature that this machine has, that I do run occasionally, is that, like the VSC 6000, where you can take your Irish and shrink it down, there are various filters you can put on here to block X-rays from going through. So you're only looking at a portion of the spectrum rather than the whole spectrum. And we have that capability of putting in different filters. And they don't go right in the machine right there.
Tom, if you're laying the stamp on top, so in that case, you're not running in a vacuum, correct?
Yes, I am. The collimator's in a vacuum. Where the X-rays are gathered and counted, that's in the vacuum. That's the vacuum.
The stamp is never subject to a vacuum.
No, that's, no, it's open up the air, it's not in the vacuum, right? The collimator's in the vacuum.
How reproducible are your bars? In other words, what's your margin of error or error bars? How reproducible are these readings?
How do I get the largest readings?
How reproducible are the readings?
100% reproducible. You could take the stamp and a week from now, go down there and get the same result.
So every time you're going to measure like 5,000 counts, it'll be exactly 5,000?
If you measure in the same place, the answer would be yes. The answer would be yes.
I thought the question was, it's 5,000 plus or minus, it's got to be some.
Yeah, there's got to be some area.
I thought that's what the question.
Yeah, that is my question. That's exactly.
Well, the sample size is 3 millimeters by 4 millimeters. So, if you can hit the same sample point that you did, then you can get the same results. But, I don't know what the difference, the difference is very, very minor. It's not significant. That's why I run it at 3 minutes, because I want to check this. I want to check these smaller peaks.
You're looking for the patterns.
Okay.
I get that part, but there's got to be some
Yeah.
background.
So the last machine that we have is the FTIR, which is basically, you can look at fingerprints of the gum, of the organic dyes, and the pigments. But the spot size is less than 1 millimeter. and you get results that look like this. Once again, these are the Douglas stamps, and I was looking at the shiny gum versus the dull gum on the back. And I ran this on the dull gum with 40 scans of each one, and this was the curve that came out for the shiny gum, and this was the curve on the dull gum. So there's one thing very noticeable, and that is these two peaks look like they're about the same. So, you know, did the dull gum have some of the shiny gum ink? Okay? And then you've got some peaks over here that aren't in the shiny gum ink. So, in using the standard libraries, if you look at dextrin, wheat starch, you get a very similar peak over here, which matches that. And if you look at polyvinyl acetate, you match up these peaks. And if you then go on the machine and match, which is on the machine language is called peak picking, where you go to the top of the peak and you press a button and it says this is 785 wavelengths, you know, and you go down here and sure enough 785, you know, you get the peak. You can see that the dull gum was a combination of wheat starch and polyvinyl acetate. And the shiny gum was purely wheat starch. That's what the FTIR allows you to do. It allows you to look at the organics, or the organic compounds. You can look at compounds. The XRF looks at elements. The FTIR looks at compounds. And if those compounds are in your library, you can come up and figure out what you have.
So we were lucky to have that wheat starch in one.
Yeah.
And Tom, one of the things that we did on a cover is we knew there was gum underneath the stamp on the cover. And we were trying to figure out if next to the stamp there had been gum. And that gum would have soaked into the fibers of that cover. You could not have cleaned it out. And so if the organic material had been there, we would have seen it. And that's, so you can do the presence or absence at the same time.
But just to tell you, just to show you, this is probably the most detailed slide that I have to show you. Is I looked at the chili stamp again, and I looked at the green, and I got this type of curve, and I started identifying what was under it. And this is like a 6-hour analysis to figure out what's under it, because what's underneath these curves stuff are hidden, and you have to use a subtraction method to get at it. And you can see that in my subtraction method, I'm able to pick out, you know, chrome yellow, calcium carbonate, Prussian blue. But let's really get back to this, which many of you read in the Collectors Club. The hypothesis was the error stamp, the 233A error, the ink on the error stamp was the same ink as the 230, not the 233. That was the hypothesis. If you look at the VSC 6000, where we looked at reflected curves, you can see that 3 of them have a very similar curve. 1 of them has a significantly different curve, suggesting 2 inks. If you plot those, which you can take all that data and plot it on a graph, you can see that there's a strong correlation between those, and then you got your outlier, which once again suggests that it's a different ink, 2 different inks. If you look at your XRF components here, the average 1 cent looks like this. The average error is that, which is very similar to that. And the 4 cent, completely different. You're completely different. So you're leaning once again saying the error inks are probably in this area here. And if you go into the FTIR and you look at the readings you get, 230 and 233A, the 1 cent and the error stamp, have a high Prussian blue peak. Very, very high Prussian blue peak. And everything else matches up pretty close. If you look at the next one for 233, there's a high ultramarine peak. This peak, the red line, and the other red line before it comes from the library studies that have been done. The library studies have been done around the world, and all this information is available to you. You just call it up in your library search. And so you can come up with that. So basically end up saying that, yep, there were two inks, the 233As were the same ink as the 230. And 233, the ultramarine 4 cent is ultramarine, not Prussian blue. So, conclusion, machines complement each other. You have to understand what you're trying to look at and what you're trying to determine, and see if you can come up with a conclusion that'll fit your hypothesis. In many cases, you might not be able. I was doing something for Doug Lehman, and I could not prove what he thought was happening. I just couldn't do it. Why is it important? Because we understand our collections better. We share knowledge by writing all this stuff up. There's probably been well over 120 people that have come and used the equipment, and they've written it up in all different scientific philatelic journals. They've gone from the Mexican Journal to the Philippines Journal. They've been in all different journals, the Collectors Club, the U.S. Stamp Specialist, the London Philatelist. You keep seeing scientific articles popping up, even in the AP. You see scientific articles popping up because people have all these questions, and they're now moving to science to answer the questions. We have scholarships. The National Postal Museum has scholarships, and the Institute for Analytical Philately has scholarships available. To come to the museum, propose a study, come to the museum, do the study, write the study up. And the Institute for Analytical Philately is having their second symposium at Chicago PEX next year. And if you want more information about it, you can obviously talk with John Barowitz and Mark Schwartz, directors of the IAP, and plan on going. If you do plan on going to Chicago PEX, please, I can't stress this enough, we're having our symposium there. There are 2 blocks of rooms. There's the Chicago PEX blocks and the IAP block of rooms. Please register under the IAP block of rooms if you're going to attend the conference. Because, let's face it, if we don't sell all our rooms, we're going to be charged for them. And it's just a pure, simple thing saying, I'm going to register under IAP. It's the same rate as Chicago PEX, but, on ours, we're required to have a certain number of rooms because of hotel issues. Anyways, if you want copies of this proceedings, you can go online and get a digital copy. And if you send me an email, I have a couple books left and I can send you a copy.
Can I make a point?
Sure.
Tom talked about scholarships.
Yeah.
There's no cost from the museum for showing up and doing the analytical work. And there's a person there, like Tom, who will help you, who knows how to run the equipment. The scholarship is not for the analyses. The scholarship is to cover, in IAP's case, to cover the cost to get you there. Your airfare, your hotel rooms. We will provide up to $2,000 for people who want to go to the museum or any place else to get the work done.
Do you have any good deals on hotels? Because that's the only thing that keeps me out of Washington. Yeah, government rates.
Depends how far out of the city you want to stay.
I just want to stay close to you.
Well, then, you're stuck at $149,
Okay, so
$189.
you're-
Yeah.
Okay, that's it. So I take the in-ground or whatever it is.
If you stay out on the metro, you can get down to 120.
Okay.
And you just take a metro ride. We're right next to Union Station, so
Okay. You guys don't have any locker rooms or government rates?
No.
or anything?
No.
But if you get a scholarship, you don't have to worry.
How long a course does somebody have to take to know how to run this machine or these machines?
Well, the micrometer is on and off, on and off. Okay, now you're trained.
My dog can do that one. Maybe,
Maybe.
with a little bit of treat there.
He's holding a phone in his mouth, maybe. But the VSC 6000, depending upon what you want to look at, maybe an hour and a half. The XRF, 20 minutes, and the FTIR is 2 or 3 hours. It's the hardest. I mean, getting the data and doing the sampling is very, very easy, but then it's analyzing the data. That's the hardest. That is the real hard thing to do.
So oversimplified, if I had 2 stamps and was willing to drive there or fly, I could bring them in, someone that would help me. By the end of the day, I'd have analysis of those 2 stamps.
Yep.
We book up ahead.
Yeah, you gotta book ahead.
Of course.
Yeah. But, you know, I mean, if they're 2 stamps, you probably have the analysis done in an hour.
Because as one example, in the canal zone, there are 2 printings of number 14. But except for rare stamps, we can't tell them apart. Can we tell them apart? I don't know.
I don't know.
Put
Bring
2
them in.
of the easy ones, and it's done.
Give them to Doug. Give them to Doug or Don. Don will bring them. I mean, they'll come
Trust
in.
them.
They're not gonna have some? No, I'm thinking of Dick Bates. You can do the Dick Bates.
Yeah.
Dick Bates will bring them in, because he's in every Wednesday or
Has
Thursday.
he been in there using that machine?
Once or twice.
Okay,
He's got plans to come in and use it.
Good.
But Dick, if you give him to Dick
I see.
Bates, he can bring him in and I can give you all, I can give him, who then give you all the analysis.
Tom, what's the history of this equipment? How long has the museum had it? And how did it find acquiring?
The museum has had the equipment for about 4 years now, 5 years now, and all the equipment has been acquired through grants. The museum has not purchased any of the equipment. The story is with the VSC 6000, Alan came up to me and he said, I want you to apply for this grant the day before it closed. And I wrote a grant application and I got a quote from a vendor and submitted it. And 4 months later he came up and he said, by the way, that grant application that you wrote just got funded. And that started the lab. So we started the lab, it was out, the VSC was out in the library, then I moved to a very small office, and then I moved to this larger office in the library, and I've added all the equipment through grants. Just writing grants.
Thank you very much.
I have one more question.
Tom, clarification. Fred asked about how long does it take you to run the machines to get the data? And then you made a comment about the interpretive process is what's important. How much training or experience is necessary to get the data and then interpret something you're not looking for?
Once again, it depends upon the instrument that we're using, but I would say we could do it in a day.
Okay.
And come up with some answers to your questions. As long as you bring in enough samples to do the study. I'm not going to do it, I can't give a solid answer based upon, I have one stamp and I want to compare it to another stamp, because I don't know what the population of stamps look like. Okay, I mean, if this is the only yellow stamp ever printed by Venezuela, and it isn't the error stamp, all the others are green, you know, we could look at it and say, yes, it is. You know, and we could prove, yes, it is, that that's the only known one. But, you know, if you're you want to compare, have a lot to compare to come up with a general conclusion. One-offs are hard to say it's actually what it is. 1847s, there's a lot of them out there. Hawaiian stamps, there's quite a few.
And in one day, it's difficult to learn statistics and scientific method, but at least from the data standpoint, you guys, you folks are great start. Ladies and gentlemen, let's thank you.